Next up, as Matthias put it, we've got beautiful segment routing on the agenda. So I'd like to welcome up the boss, Krishnan Thirukonda, on segment routing traffic engineering.
Thank you, Kyla. Thank you. So this was a great segue into the next topic, where we are going to be talking about deploying and managing segment-routed traffic engineering networks that are made easy with Crosswork Network Controller, which supports automated provisioning, visualization, real-time optimization, and bandwidth use cases. As Matthias mentioned, visualization is a very important piece for operations teams. When you get into traffic engineering, where you're doing a lot of custom routing, custom paths, this is very key for anybody that is in charge of running this network and delivering services. So I thought we would quickly recap why you would do traffic engineering, because it's another layer of complexity. There must be a reason why you would do it. It's mainly to summarize, to get additional services where the objective is to do more than what your normal routing would give you, just OSPF or ISIS. Always will route on the shortest path based on end-to-end IGB cost. But if you have a reason to do a service that requires some way of picking links on a different criteria, like you want end-to-end latency to be optimized, then you pick all the links that end-to-end A to Z, ingress router to egress router, you get lowest latency. Another example for link preference could be where you want to pick only links that have certain properties, MACsec, for example, where encryption is required, or don't, meaning avoid links that have some property, like crossing inter-country links, right, so that you keep traffic within the country. There are lots of examples of this. Other reasons why people do traffic engineering is to have a service that requires, is very intolerant for packet losses, and the customer is willing to pay extra to get 2 copies across your network. And it would kind of require you to actually send it to 2 different sets of routers and links, because if you send it, if they share anything in common, then you have kind of defeated the purpose. So that's called sometimes disjoint paths, and that's another reason to do traffic engineering. People used to deploy it with nailed up paths, with you pick in manually, that doesn't scale when you run a large network. So that would be another reason. There are a whole set of bandwidth use cases that require traffic engineering, where you either want to protect bandwidth given to a certain set of services, or you want to use sometimes called scavenger class traffic, where you want to pick the places where bandwidth is available to deliver service, even though it goes in a very long path. But you want to use your available inventory. And then the last one is congestion mitigation. This is usually very tactical, meaning if there is a problem in some hotspots in near term, in short term, you can't really go and buy additional circuits, links, wavelengths, whatever. So you have to have a way to remove some traffic out of that hot link. So there would be some possibilities of custom routing some traffic. So that would need traffic engineering. So why do we say, in this talk, segment routing? Because segment routing has some favorable wins, some technological advantages compared to what we used to do with MPLS, with SR-TE. With SR-TE, you had to have the technology embedded in the routers do the work for you, which meant all the intermediate hops need to keep state. If you, it was usually deployed, and a lot of you probably did it already, in a very sparse mode, meaning you deploy only for a few services, or you did it in a full mesh in a very small domain, because in full mesh, you end up with n into n-1 kind of a state in all your core routers, which are supposed to be simple and not require a lot of maintenance and not have dynamic resource consumption, which all this dynamic state would consume. Segment routing uses source routing principle, meaning you can actually put all these segments that a packet has to go through in the packet header and send it. All the intermediate routers just look at the segment header and switch it out. So that's a very short summary of how segment routing works. With SR-MPLS, these segment identifiers are just MPLS labels. With SRv6, they are IPv6 headers. So the intermediate routers are just doing what they're designed to do in hardware without having a lot of awareness of what the service or the application layer is going to be. And so that makes the fabric very simple, stateless, and then but you can still achieve any kind of traffic engineering, any kind of a fancy custom paths as you want using controller, right? This is where the controller comes in, because controller has all the intelligence. It's external to the router. It's a software appliance, meaning you can throw as much RAM core as you want. You can run it in highly virtualized environments where you can get more resources easily without having to upgrade or touch your hardware routers in the field, right? So it usually runs in a data center and can be very powerful and more easier to add more innovations as they come in. So the SDN, software-defined networking approach, where your software entity is defining your paths, comes into play here. And definitely you can achieve more pervasive traffic engineering, where you can actually offer more services that are requiring traffic engineering by using segment routing, right? Either SRv6 or SRMPLS, using a controller that can do all this calculation for external paths. So when you actually deploy traffic engineering, like the previous talk also covered some of this, when you do custom paths, you don't want to actually have paths nailed up, right? If you have paths that are like manually calculated and fixed static paths, those are not going to scale when your network actually changes, because you have links and nodes failing, fiber breaking, things like that happen. So one of the core important pieces for doing scalable traffic engineering is to have a dynamic path calculation engine, which means you can actually ask this software entity to do the path calculation and also be stateful. Stateful means any path it has issued, it keeps track of any underlying topology change that may impact that path, and then it goes and recreates it automatically, right? We call it always on closed loop. And this is very important so that there is no need for a human intervention to happen when you have outages or changes even in bandwidth use cases. For example, bandwidth patterns may change. Now you want to read out your bandwidth demand traffics, then you can do that automatically. You need an engine that can do that. The next thing is to actually have visualization of paths. In this network where you have lots of paths, where you're not doing only a few that you can even remember, that you gave this path to this extremely high important customer, and it goes through all these nodes, that kind of thing cannot scale if you're doing pervasive traffic engineering, where you're able to offer additional value-added services using traffic engineering. So what you need is definitely an engine that not only provisions these traffic engineering policies, we call them policies in the segment routing world, which are basically equivalent to your tunnels in RSVP land. But you know this first thing you need to be able to visualize this topology of your network without having to build tools or yourself. You need to overlay the paths that are being deployed from traffic engineering point of view. And you want to see this in the context of the service you're delivering, because it's not just a traffic engineering part. You're doing it because you're delivering a end-to-end customer-facing service, a VPN of some sort. And then when you go to the VPN details, you want to see what traffic engineering policies or paths are being used for that VPN. A lot of our customers are doing multi-vendor, so a lot of this has to work in a multi-vendor network. So this technology has to work based on standards, and we'll see how we are implementing on CNC side. In terms of provisioning, we want to go with model-based provisioning. That should be very easy to understand in the context of this conference, because our NSO product is what is used in CNC to do the provisioning, and it has basically translation capability to any kind of vendor router out there. So we'll go faster on that one. Path performance metrics, you saw an example of in the previous one, but that is very key, meaning if your traffic is going, you're delivering a service, you want to see a priori or on a proactive way, what is the traffic going to experience from delay variation, packet loss, and when you bind it to traffic engineered paths, you want to actually send packets, sampled packets, to measure these things on those paths, and you want it to be integrated, easy to not only create, but also to observe, right? Meaning from the operations point of view, you want to see visualization, and you want to see threshold crossing alerts being raised so that humans can be pulled in when needed, not having to be staring at screens. And then the bandwidth use cases are very key, because that's where the industry is going. Now we want to offer more and more use cases. We want to give bandwidth guaranteed service, or we want to leverage more out of our inventory of all the things we have deployed, and we have capacity at some places which is not used and capacity in other places. The congestion mitigation thing comes in very important. So these can be a very important topic, but it's also adds another layer of complexity, and you need more algorithms and things like that, where the controller becomes a very key piece as you consider deploying something like this. So let's quickly recap what we are trying to do with Crosswork Network Controller, right? So on the top, you have the user, and the user is actually managing, deploying network with services and traffic engineering underneath. In a normal case, the user may be an operations staff that's wanting to get a pane of glass kind of view of what's going on. In terms of service turn-up and deployment and updates that may be coming through API, right? So you need basically both, and both works. On CNC, and you see on the top we have a modular software, what we call as Crosswork Network Controller with Crosswork apps. So if you look at provisioning, visualization, optimization, service health, closed loop automation, these are built as software apps where you can deploy parts and not deploy parts. They're tied to licensing as well, so you get some kind of a flexibility there. But it's deployed as one app that is able to give you integrated experience in terms of, when you deploy, when you provision something, you can also visualize it. You can have, if you're doing TE, real-time optimization always on. And if you're doing services, VPN services, you can have service health monitoring that's going to consume the policy monitoring and use that to give you alarms for that service-specific alarms. So all of that is presented in an integrated fashion. Now, there is other layer of components that you see. These are the things that are going to talk to the routers themselves. And this is where you can see, the multi-vendor network itself is at the bottom. And you want all these interfaces to be standard-based or industry standard so that it can be easily deployed in a multi-vendor network. So starting from the left, the path computation, this is where we get the real-time path computation capability, and that's actually part of our iOS XR. We use the path computation engine that's built into iOS XR, and in this complex, it'll be deployed as a iOS XR 9000, like a virtual router. You can even deploy it on hardware router because it's just iOS XR, and then it actually talks to the devices using standards-based IETF standards are there for BGP link state and for something called PCE protocol, Path Computation Engine Protocol. This is the protocol that routers, head-ends, use to ask for paths or to report paths, and then a PCE is able to use this protocol to reply with the path calculation. Then you have to do really good path calculation, which is bandwidth aware, you need to build a traffic model, right? So the traffic model collection of KPIs that tell you how busy an interface is from traffic stats perspective, how much traffic is flowing through each LSP, like an SR-TE or even RSP-TE. All of that needs to be collected, and that could be, if you have attempted it yourself, could be a pretty big resource requirement there. So we have built it as a scalable layer, which goes and connects to routers and collects statistics, and then feeds all the apps that need it at the top. And then you have the configuration engine, which is NSO. So NSO is doing all the translation for a device agnostic service. You want to create an SR policy. You don't want to worry about if it's a Cisco router or not. But our system using NSO in underneath will translate to any vendor router below. You get out of box. CNC is what we would call as commercial off-the-shelf product, right? You buy it, you get a bunch of capabilities. Does it address everything you may need? It probably addresses 80, 85, 90% of what you want. And this is where the developer community comes in, where you add extensions. And a lot of the extensions will be particularly when you deal with other vendor routers. With Cisco, XR, and XE, you get out-of-box functionality. You may still want to enhance it. We can put it as features in the product. That's where our intent is. But if you have to do something really quick, you can also extend it. Particularly for the configuration, it's really easy because it's the same design and implementation patterns as NSO. So here's a quick thing. So the next few sections, I'm going to take each of these topics, the ones we said are challenges, how we address with CNC. So the first one is, how do we learn about the topology that you've deployed, and how can we visualize them, and how can we learn about the LSPs you have deployed and display them? So I won't go step by step, but in short, we have your routers here that can do BGP link state. So BGP link state is a way to distribute the information in your OSPF or ISIS to an external controller, right? Instead of having those external controllers sit inside your ISIS or OSPF, we use BGP to stream it out. Now the controller, once it has all the data, including the TE extensions, traffic engineering extensions to OSPF and ISIS, we can, meaning the CNC, can actually go ahead and use that to calculate paths and to also visualize it. So that's a key thing that we are doing there. The next thing is when you create policies, that's where the routers, head-end routers, will use PCE protocol to request. You have to configure who is the path computation engine on your routers, and then the routers can to report their policies or query them. So that's the key thing here. And on CNC, this is how it looks. If you look at this picture, and I don't know if it's visible, the topology in the back has colors, right? That colors are actually coming from collecting traffic statistics. So that's happening in parallel. If you look at that, there's a GNMI SNMP path. So we have CNC. As soon as we discover your devices and links, we automatically start collecting traffic stats, and then you get this kind of picturization. And then when you navigate to a traffic engine page, we show all the LSPs that we have discovered. Again, these are all reported by head-end to CNC through the SRPC path. And then you click on any of them, we can actually render which are the paths, hops, segment routing segments that these paths are going, including adjacencies. A lot of information that engineers would have to go into the edge routers and do a show segment routing. Every vendor has a similar command and see the path and interpret it. You don't have to do all that. And all of your team has access to this information, so you can very easily, without requiring everybody in your team to have access, get this information, and it's always on, meaning it's always available. Here's another example. I pay attention to the very top. I've shifted to a different screen. In this one, I'm on a VPN service. And if you look on the side, you see which VPN service we are talking about. And that particular VPN has underlaid transport. That's not just IGP routing. In this case, we are using SRMPLS. And you see all the policies that are relevant for the set of PEs where you're delivering this particular, happens to be an L3 VPN. And as you can see, we do support SRMPLS, SRv6. For multicast transport, we have TreeSID or P2MP SR, and then we have RSVPT module as well. And you get the exact same details there, whatever we have from TE point of view. If you go double-click into the policy itself, this is very interesting to anybody who is engineering staff, operations staff, anybody who has to keep this network working and troubleshooting. What is this path using, right? In this case, it happens to be an SR-V6 TE path. As you can see, we are using microsids here, and we're using microsids for adjacency. You're going to node 5, that interface, and then you're going to node 7, that interface. A lot of this in the past with RSVPT used to be done on spreadsheets, program it, but to confirm this is what the route network is doing, you'd have to go and do CLI commands. And not a lot of people would understand or have the expertise to do it. But now your operations staff, they may not understand anything, but they can look at this, and when they call your escalation staff, they can tell them, this is what I'm seeing, right? So, and it's live, meaning every time you click, we have the latest information. Here's all the constraints and metric that was used, which path computation engine was contacted. All of that information is available. Here's another quick view. With segment routing, we are getting a lot more features that are simplifying how to deploy. So Flex Algo, IGP Flex Algo is an extension to OSPF and ISIS, where now you can have many lanes, if you will, with just the same routing protocol. And the key thing now is how do you visualize what the Flex Algos are doing. So this is a simple visualization of showing a dual plane network. You created 2 Flex Algos, and you can see which links are common. The brown links are in both planes, the red plane and the green plane, or red plane and blue plane, however you do it. So this is going to be super useful, particularly when you go to SRv6, because with SRv6, just with Flex Algo, you can create many lanes of traffic without even going to traffic engineering. So the optimization engine and how is optimization done, right? Meaning, when you request for a path, again, I won't go through step by step, but you see that you start off by configuring through our UI or API, right? This is going to cause, there is a, if you're familiar with NSO, we have a function pack called Transport SDN function pack, TSDN, which is actually having all the modules for SR-TE, RCPD, L2 and L3 VPNs that ships with CNC when you get it. So you would use that from the UI or in production use cases, mostly from API, to create a policy that gets, the internal NSO is going to contact the device and push it. It is also going to translate to the type of device, if it's a XR or XE or other vendor. And then the device itself, at this point, the magic is happening on the router software, the NOS, Network Operating System, which has the capability to use PCE protocol to, and then the configured PCE, Path Computation Engine, to ask for a path, which will happen to be inside CNC complex. CNC will do the path calculation, and send the path back, except for one case where if the constraint includes bandwidth, meaning the path is asking for a bandwidth, it'll actually go upward one more because the traffic model is actually resident inside the what we call as optimization engine. Optimization engine, as you can see on the right side, is collecting all the traffic stats all the time and keeping the traffic utilization model of your current network, and it can do the path calculation, feed it back to the SR-PCE. This is again standards-based called delegation. So the head end, instead of doing path calculation itself, is delegating the path computation request using PCE protocol to the PCE, standards-based. PCE can actually further sub-delegate it to the another layer of delegation. All of that results in the path getting to the head end, and the head end can use it. And this is always on, right? So now this is where the stateful piece comes in. If the topology changes, right, because a link failed, a fiber failed, the PC will know of it. PC keeps a state of all the paths issued, and it can recalculate the path and push it down to the head end. This can also happen if the bandwidth pattern change, and there is a better path from bandwidth point of view. So how do we do multi-vendor in this case, right? How does CNC support multi-vendor? So the first thing is for configuration. I won't dig deep because in this whole conference, the NSO product was talked about, and this is the key piece to do translation for every device type. And we have service models, as I said, in the TSDN function pack that you also get with CNC that does it automatically, and you can implement it for other vendor routers. Telemetry collection. So if you are collecting telemetry, which we need for traffic stats and for service health monitoring, for all the Cisco devices, we are collecting it out of box. If you want to do for other vendor routers, there are adaptation layers where you can go and put equivalent KPIs and normalize. And that would be either the job of Cisco professional services, or they can train you how to do it from your development staff as part of the deployment. And then the control plane protocol, the BGP-LS, PCE protocol, those are all actually standards-based, right? So there will be an element of interrupt testing in your labs, working with the other vendor to make sure that they are compliant. But we have a good starting point that we have participated in interrupt tests. If you're familiar with the MPLS World Congress, a lot of vendors participate, and the EANTC hosts a multi-vendor interrupt test, and different technologies are focused. The one that we did in 2024 had the transport SDN as a key focus area, and as you can see, CNC participated and ran a lot of test cases with a lot of the network equipment vendors. You can click on that link to get the public list of test cases. The white paper there has all the test cases, the vendors that participated, and the pass-fail kind of things. And then here's a quick snapshot of that effort that we did, which shows in CNC UI all the other vendors out there. And this is key, right? The fact that we can work with, when we say standards-based, we can actually work with other vendor routers, and we have proven that at ENTC is a great resource for you when you get started on your journey. So one quick thing, we talked about how we want to measure policy, right? The traffic, what the traffic is experiencing when it goes to the policy. So here we are depending on technologies that are on the routers themselves. Think of this as a TWAMP, but when you bind TWAMP with segment routing, you get what in Cisco we call as segment routing performance measurement, SRPM for short. Now, these are configured on the routers, so you have to actually extend your automation as you create policies to also enable SRPM and SRPM-related configuration parameters. And then what you get is that you get telemetry, meaning you can do show commands to see how your policy is measuring the delay through the policy, delay variation, packet loss, and so on. But in reality, with automation, you want it to be integrated and presented on your controller view, right? So CNC will automatically, as you provision a policy with SRPM, will also measure collect the telemetry, and you can see the visualization, and you can get threshold crossing alerts. Now, TCAs are bound to services, because if you're delivering a gold class service, the threshold may be different than a silver or bronze, right? So we have in the VPN module, what we call a service health, where you can actually tie what we call as SLA profiles with thresholds. And these thresholds depend on the router actually reporting those KPIs, and then we collect, compare against thresholds, and then we report it. So going back to the view I showed earlier in the traffic engineering view where you have all the bunch of policies, you see the little bar graph icon. When you click on that, you get a live view of what the last reported measurement of delay, variation, of course, traffic. And in the next release, we are planning to add loss as well. So you get that all at the fingertips here. And if you go into the VPN services view, again, whatever you get under traffic engineering view, you also get in the VPN service view, which is key for actual service delivery, for customers that may start calling in and complaining, right? So you want to see, in the context of this target LDP 1002, what are the policies and what are they experiencing? And you will see the green icon where it says health go to degraded if it's not meeting the configured threshold alerts and stuff. We also have a trending, so if you want to go and look at historical view of what happened in the past, we show you not only the KPIs. I don't have an example in this view, but we also have events, as you see, where if the path changed, we will be able to show you a red dot, and you click on it, and you'll see what paths were there in the historical, like what was it before when it changed. So that's, again, key. Going back to the previous session, running custom paths, it can be a challenge if you can't see it. Requiring you to go to routers and check those things are really not only more effort, but also do you have the skilled staff that can do it all the time, 24/7. So with this one, anybody who is staffing the night shift can do it and decide, this is what I'm seeing, and call the escalations team. So that's very key. I'll kind of keep it brief when we go into the bandwidth use cases, because there's really each of these can be hour-long sessions, right? So we will kind of go through at a high level each of these things, and I'm happy to discuss this with you at the booths out there. But the top 3 things are what we support in shipping CNC, and we are doing a lot more in this area that's coming up. Starting with bandwidth on demand. Bandwidth on demand is easy to use. One of the things with the bandwidth use case you will realize is that it does depend on your network to have, for example, QoS. And the more fancier you want to go, the more, let's say, configuration burden is on having a day 0, day 1 type of config ready to guarantee the things that CNC will assume it's there. So, but with bandwidth on demand, it's a really lightweight bandwidth guarantee protocol service. It actually uses SR optimized path calculation paths. What that means is that it is going to use prefix SIDs, right? So you can actually create really long paths, and you can cross domains by using prefix SIDs. But what also that means is that ECMPs will be used internally. And if your traffic is high entropy, meaning a source and destination address is highly varied, and you can roughly get equal usage in ECMPs, this is a good solution. So it's a really soft bandwidth guarantee. So you give a bucket of bandwidth on every link to CNC, and then CNC creates paths assuming that it can fill up that bucket, and that's how that works. Circuit style segment routing TE, there is IETF standards for that, and it's really like a circuit, meaning it goes hop by hop and books bandwidth. This is very close to how RSVP TE would do it. It's hard bandwidth guarantee, it has path protection, and it's really used for cases where you want a circuit-like experience. When it comes to circuit emulation, where people are moving their optical and legacy SDH Sonnet services, we even have hardware cards that are actually mapping those services into IP, overlaid on IP, and then that would run over such services. But you can use it for anything. But basically, it is ordering packet ordered, guaranteed, symmetric, meaning both the A to Z and Z to A go on the exact same paths, and path protection can be used with working protect and backup. And then congestion mitigation, I'll cover in more detail because that's a very interesting use case that may be useful for more folks. So this is the screen on LCM, local congestion mitigation. It detects congestion on certain links. You can set threshold at which the link should be considered as congested, and then it'll go and propose SR-TE policies that can bypass that link. So you have 2 nodes A, B, and then you have that link congested, but there are other ways roundabout through the other network hops. It'll go and actually propose, as in this example, On node 3 and node 5, there is a link that is, threshold is 18%, but it's running at 21. It will actually tell you that I can, meaning CNC can solve this by creating some policies. Today, default behavior is human in the loop, meaning it's going to show you as an operator, you decide you can do the preview there, and then you can commit, and it'll go and create those policies. If you don't like it, you don't have to. We are actually moving it to automated. We need to do some more things to make it fully automated. We are working on it. Again, this is a little bit more detail. So if your nodes A and B has a congestion, meaning the traffic there has crossed the threshold that you have set, this is always seen by CNC because CNC is constantly getting traffic stats, and it looks at the threshold that you've configured. And once it detects the congestion threshold has breached, it automatically goes and calculates, do I have paths that can go around it, even though it's longer, and I can pull some traffic over, right? There are more details here. I'm happy to discuss with you, and we have a white paper on our Cisco.com on this as well. But basically, the user is shown the options. If the user says, I like it, go for it, it'll go and create it. The user doesn't have to actually go ahead and create the hop-by-hop paths or specify anything. We have it all built into the system. We just have the user today to look at it and press one button, and all the policies will be deployed. And of course, we manage it, meaning when the congestion goes away, we'll throw another alert saying, you don't need these policies anymore. Should we remove it? That kind of thing. Now, as I said, we are working on making it automated. Today, we can do automated by using a setting, but default is manual. There is so much more to talk about. For example, with SR-V6 TE, everything I showed you, for example, other than the bandwidth use cases, is possible with SR-V6. SR-V6 TE binding to VPNs, Flex Algo, and then when you use Flex Algo, the VPN payload, how you configure VPN, has a slight difference. So that also we support. Circuit style we support, multicast. And then we have API. So if you want to run this policy, we have local congestion mitigation out of the box for you. But if you want to use the notification of congestion and write your own custom behavior, you can do that using our API. That's just an example. The full topology data is available. If you want to decorate your in-house developed software, you can use this data. And what are we working on specifically about segment routing? We are working on a lot of things on CNC. It's our fully integrated solution for customers that want most of the work done as in the product, right? So that's CNC. So the thing, iOS XR supports demand matrix now, because if you use SR-V6 and you're using Flex Algo with counters of how traffic patterns are going, we can get a whole view of demand matrix counters. In CNC, we're going to have visualization for that. We're going to have path visibility integration with what was shown in the previous, with PCA. Then we have LCM automated mode, and the thing that we're waiting for is multiple segmentless support. In short, all I want to make sure you understand is that if you're really wanting to go into the journey of segment routing and want to deploy TE pervasively, CNC makes it easy for you to get that started with automated provisioning, visualization, real-time optimization, and support for bandwidth use cases. That's all I had. Any questions? I guess we're ready for coffee.
Yes, I think so. Well, you can always find Krishnan out in the coffee break room, but you can go ahead and now take a break until 10:30. So we'll be back here at 10:30 with the Three Musketeers. So go ahead and have a break. Thanks,
Thank you.
Krishnan. Thank you very much.
Yeah.